So today is the third day. So before that, I'm going to instruct two instructions. The first one is at least 80% attendance is required for the E-certificate. The next one is the final day, Saturday, there is the assessment will be taken. Okay. So you have to complete the assessment as well as the 80% attendance is required for your E-certificate. Okay. So now we welcome our chief guest, resource person, Dr. Vinod. So regarding the resource person, so he has received his BE Triple from SRM Engineering College, Madras University, Chennai in 2004. He has done his ME in Power Electronics and Drive in Jerusalem College of Engineering, Anna University, Chennai in 2006. He has completed his doctoral degree under Faculty of Electrical Engineering in the year 2021. He has 18 years of total teaching experience. Regarding the awards and achievements, he has received Best Teacher Award, Best Assistant Professor Award, and Best Commitment to Service Award. And he has received the Best Paper Award in the IEEE International Conference on Computing, Electronics, and Electrical Engineering in 2012. So regarding the funds received, he has received $200 US dollar and appreciation for fostering and ecosystem bridging government industry by Texas Instruments. He has received a sum of rupees 30,000 for conducting one-day seminar from IET student chapter on 4th May 2023. He has received a sum of rupees 50,000 for conducting two-day All India workshop from IET student chapter on 7th and 8th June 2023. He has received an approval for 2.4 lakhs from EDCell Tamil Nadu Innovation Voucher Program, design of smart residential drainage block remover in sewage pipes on 26th May 2023. He has received an approval of for rupees 15 lakhs from MSME Innovative Scheme Idea Hackathon 2.0 for proactive traffic signal clearance for ambulance service on 26th June 2023. He has received financial assistance for the project hands-on workshop for school teacher to improve science teaching, a sum of rupees 1,58,000 from Department of Science and Technology, DST. Okay. Totally, he has published 25 papers in reputed international journals and conferences. He is a senior member in IEEE. He is a lifetime member of ISTE. He is a lifetime member of the Institution of Engineers India. He has published a book titled Circuit Theory by Rakshana Publications. So it is over to you, sir. You can start your program. Vinod, sir?
Yes, sir.
It's over to you, sir.
Yeah, share is not turned on, it's saying, sir. To share, it need permission, it seems.
I changed you as a co-host, sir, actually.
No, I am just going for share. If I ask for share, it is saying sharing is not turned on. Host is still allowing to share this meeting.
Okay,
It's
okay.
you have to allow, sir.
Okay, sir, okay. Hello, ஆளுங்கிறாரு அவர் போஸ்ட் மாதிரிலாமா So I changed you as a host, sir.
We'll check it, sir.
Okay, sir.
No, it is showing the same, sir. Host is not allowing to share. So if just I press the share button, it says the host is not allowing to share for this meeting.
என்ன சார் பண்ணலாம்?
நம்ம இங்க ஹோஸ்ட்ல தானே பண்றோம்.
So otherwise you just share the PowerPoint to me, sir. Through WhatsApp I will share.
Yeah, 1 minute.
Okay, sir.
நேரத்துல போட்டுருக்காங்க.
இல்ல அவர் ஹோஸ்டர் போட்ட கூட வருவாங்க. நேற்று அவங்களுக்கு நேற்று அவங்களுக்கு வரல. அவங்களுக்கு அப்புறம் அவங்க சொன்னாங்க சொல்லி அவர் இங்க இருந்து நான் தான்
Shared my PPT, sir.
Okay, sir. Okay, sir. I'll check. சார் இந்த ஆலிம் ட்ரிபிள் அனுப்பிட்டேன் சார். ஆலிம் ட்ரிபிள் அனுப்பிட்டேன்.
I think I have logged in from my mobile as well as from laptop. I think you are made my one as an host. If you make me that another login also host, then I can present. I think so, sir. It will be convenient if I be able to control.
ரெண்டுக்கும் வர முடியாது. அப்போ அவர் பண்ணி
First பண்ணதை remove பண்ணிருங்க சார்.
Okay, sir. So you are now host, sir. So you can go. You can make it go host, sir.
நீங்க பண்ண முடியாது. நீங்க பண்ண முடியாது. இல்ல அவரு திருப்பி உங்களுக்கு ஹோஸ்டா மாத்தினா நீங்க அதை கண்ட்ரோல் பண்ண முடியும்.
So now you are the host and you can only make you the another version as a host. So I am unable to host you.
No, sir. I have logged in through my mobile as well as laptop.
That yes is now I am changed into host, sir.
Yeah. I think it is no same thing. It is saying, sir, host is not allowing. Okay, I will check it. You have made both my login as a host, sir, or
No, sir. It's not possible. Only one host, sir.
Co-host.
Co-host only it's allowing.
Sir, Sai sir. Hello. Sir, co-host வந்து வினோத் சார் கேளுங்க சார்.
ஹோஸ்ட் திரும்ப நான் எடுத்துட்டேன் சார். இப்போ நான் யார் co-host மாத்தணும் சார்?
இல்லை. See, there are two logins from my side.
co-host மாத்துங்க.
வினோத் சாருக்கு ஒன்னு co-host பண்ணிட்டேன் சார். இன்னொரு லாகின் நேம் சார்?
ரெண்டுமே ஒரே நேம் தான் சார். வினோத் எஸ் தான் இருக்கும் சார்.
ஓகே சார், ரெண்டுமே பண்ணிட்டேன் சார். ரெண்டுமே கோஹோஸ்டா மாத்திட்டேன் சார். இப்போ செக் பண்ணுங்க சார். இப்போ ஷேர் பண்ணலாம்.
Yeah, I will check it, sir. Yeah, now it is allowing, sir.
எஸ் சார்.
Okay. Thanks, sir.
Is my screen visible, sir?
Recording in progress.
Yeah.
Sir, yes sir, visible sir.
So very good morning to all the college which is hosting. I like to thank for giving me this opportunity to present, and I like to welcome all participants from various institutions. So in this session, we will discuss about advanced battery technology for sustainable energies in EV. Yeah, we all know we are moving towards green energy, and we are moving from petrol, diesel to electric vehicle. So when we say we move to electric vehicle, the main person or the key person who is going to play the entire world is the battery which we are going to use. So there are various advancement and revolution is going on EV battery. And since I have taken this as my topic, is there is a lot of research that can be carried out in this sector, in battery of electric vehicle. So revolutioning electric vehicle performance through cutting edge battery innovation and sustainable energy solution. Okay, so you have given a wonderful introduction about me. So once again, I like to thank. I shall proceed with my presentation. So first of all, before going in, we should know what is the current market of overview over in global. So nowadays it is 933.5 global battery capacity is required, which is in order of gigawatts per hour. Year over year, the growth is around 35%. Is there is a growth, and market is around 251.38 market projection by 2035. So based upon this projection, it is very clear. So future will be on EV, and moreover electric vehicle in all modes of transports. Then expected battery demand by 2030 will be in order of the tetra. Okay, so for this, various revolution is being going on with respect to battery, whereas in material which is going to be used. So EV battery demand is projected to more triple by 2030, with the emerging market doubling with share of around 5 to 10%. So even now, if we are investing in share, if you like to invest in shares, if you invest in like battery manufacturing companies, then there is a chance for to earn income through even share. And we all know China is leading with 60% of the global battery demand as of now in 2024 to 25. Next to that is North America, Europe, strengthening domestic supply chains. Then comes Asia Pacific. We are in Asia Pacific. And the thing is, central government is taking more initiatives towards various hackathons. So even now, while introducing, they are told that I have received around 15 lakhs from MSME hackathon. And the idea behind is we have to develop our own product. Thereby, we try to reduce the import. Thereby, when we start exporting, then our GDP will increase. So that is what we say, market is expansion at a very huge rate. So we have to cope up. Then as usual, when you say when market expands, automatically cost starts to reduce. That we have all visualized with respect to solar panel. So this is similar to solar panel, which was there in last 5 to 6 years back, where the cost of solar panel was very high. Now it has become very cheap. So in near future, your battery vehicle will also come down. Okay, battery pack price feels like 20% in 2024, and as last greater instant, there was a drop when compared to 2017. So China price dropped from 30, various 10 to 15 in Europe and USA. Then lithium ferrous phosphorus battery, that is the key person which is being used nowadays. So in all electric vehicle, we have only lithium ferrophosphate batteries that are 30% cheaper than NMC, nickel, magnesium, and cobalt alternative. But when you have a plan of doing any research, it is you have to do research on NMC, that is nickel, magnesium, and cobalt. Since now it is rate is high, obviously in 1 or 2 years that will come down. Okay, the projection reaches say that $1 spent for 1 kilowatt hour will be around 35 in the year 2030. Okay, then moving into industry leadership, we all know till the leader is only China, who is manufacturing compared to other. So you have very major two companies which we can see as Cattle and LG Energy Solution. They are leading in innovations. So investment is localized, supply chain accelerating. So once if you start buying, then automatically there will be a supply chain management. Thereby there will be reduction. So this is with respect to global market. Then moving on to battery chemistry. So I have told no that we started with the lithium iron phosphate. That is the battery which now we use in electric vehicles. So there is future for we move into lithium, nickel, or cobalt, or magnesium. The three are three different combinations. Either you will go with lithium nickel, or lithium cobalt, or lithium magnesium. And there is one more which is sodium ion batteries, and the final one is in solid state batteries, which is in development. Once this solid state batteries come into picture, the size of the battery will come down. The risk in handling battery will also come down. Already we have moved because we started with lead acid. Then there was so many issues like that. Whenever there is a jump in road or when you put a side stand, there is a chance for the battery to leak and explode. But that is totally ruled out. Now we have only lithium iron phosphate, which is slightly heavier when compared to the solid state batteries. When solid state batteries come into picture, then automatically you will say this is the most safest mode of transport, electric vehicle. Okay, so this bar graph is surely showing now only lithium iron phosphate is ruling the world. Around 850% of battery chemistry market is being ruled by lithium iron phosphate, and that will move towards lithium, nickel, cobalt, and magnesium, and in near future. Okay, so LFP battery now dominates with 85% of the market share, and in utility scale storage by 2024. So up to 48% on 2021, which was only 48% in the year 2021 when electric vehicles in Europe and China they have started using, but it's slowly it is coming into our market. Now we can say that we have acquested with the more number of two-wheelers compared to four-wheelers in India. But in near future, we will even have more three-wheelers and four-wheelers. And even at that time, this 48 itself will be high and it will come down to around 35 or even 30. So next one is emerging battery technologies. So that is what I told. There is an advanced battery technologies are enabling faster charging. So why we are moving is the first reason is usually when you travel very long distance, the advantage of diesel as well as our petrol vehicle is when you want to fill the fuel, it does not take more than 5 minutes. So go into a bunk, just 5 minutes, come out, and then you can start. Whereas when you go for electric vehicle, we say you have to put your battery for charging. It may take 1 hour, 1.5 hours to get for 60% charging. But now, due to this key emerging battery technologies, when solid state batteries are coming to picture, okay, so when these fellows are going to control, they will replace liquid electrolyte with a solid material offering high energy density. We'll have fast charging and improved safety for next generation. With respect to safety, comparison with respect to material, what we need is the fast charging. So when you move with solid state batteries, we will go for fast charging. And any young faculty who want to go for research, then they can go for fast charging methods. There are so many converters based charging methods. Thereby you can go for fast charging. So already I think we might all noticed A to B, Adyar Ananda Bhavan, if you see on highways, they have an EV charging station in their restaurant. Just this is to capture the crowd. So already if you come to A to B for having lunch or breakfast, it will take 1 hour or minimum of 30 minutes. So at that time, we can put your vehicle for charging. Thereby, your vehicle will get charged with around 40 to 50%. So you can even further go in your travel, you can proceed. So likewise, there are upcoming things are happening, but it will be very fast when we go for the solid state batteries. Next one is sodium ion batteries. So when you see sodium ion batteries, they have launched a new sodium ion batteries in March 2025 with an improved energy density and fast charging, offering cost-effective alternate for lithium. So when you compare the sodium ion, so when I compared the solid state, I told it offers very fast charging, whereas when you go for sodium ion, cost is less because raw material is abundantly available in India. So we doesn't want to go with foreign countries for any option of importing. So in that case, automatically your rate compared to lithium ion will be less. And the final one is flow of batteries, liquid electrical system preferred for large scale storage with longer discharge time relatively and reduce fire risk. This is again, even though if you go for solid state, we need lithium ion batteries. We cannot throw this lithium ion outside because there is one thing which is always with lithium ion is if you say a person takes times to charge, then you will also have a large time for discharging. So can be used for any grid integration and all. So this one is the battery performance merits. The key importance is your life cycle. So this is what we need. So we have seen about what and all material. Now then which character of the battery is what we like. Usually all Indians, when compared to European countries, we go for investment and we try to utilize to the maximum core. We are not like Europeans. The Europeans, they buy a car, they use it for 3 years or 5 years, they will put for scrap. But we are not brought up like that. And among the world, India is brought up such that we use to the maximum core. So when you want to use it for maximum core, what you require is number of cycles. So if you go for more number of cycles, then you can say you can use it for longer duration of time. You have to charge and discharge. So in that also where so many improvement has done. So you can see initially when we go with the traditional LFP, which is lithium ferrous phosphate, you can charge and discharge for 3000 cycles. Again, we have to be very cautious that you should not use your electric vehicle like what we have done for mobile. So usually we have an habit, when you buy a mobile after 1 year or 1.5 years, what we will try to do is we will not wait till the entire mobile get discharged. You will have side by side, you will have a plug point, you will have charger cable being connected in your office, workplace, or wherever. So whenever your mobile goes down by 80 or 70, you just plug in, and again you will start charging your mobile. But that is not advised. When you take a battery, the battery has to be fully charged. Similarly, battery has to be fully discharged. So you have to wait till you reach your full discharge. That is around less than 20%. Beyond less than 20%, you are not supposed to use. Even in your mobiles, I think we might all notice in your mobile, the battery level indication will be in green color. And when it touches less than 20, it will become red in color. which is indicating that you should not use your mobile beyond that. So why the reason is, what happens is now your potential difference is coming down. You are able to get the current from the battery, but the potential is coming down. But since power remains constant, what will happen is your ice starts to increase. When ice starts to increase, then thermal runaway problem will come. Your mobile gets eaten up. So same case, when it is full charge, mobile will not get eaten up. But when you go beyond 20, your battery gets eaten up in your mobile. Same case in electric vehicle. So what happens is your electric vehicle, you are supposed to use from 100% to less than or equal to 15. You should not go beyond 15% of the battery. Until that instant, you are not supposed to put for charging. So once it reaches 15, then you can put for charge. So your lifespan of your vehicle will be for longer duration. That we should always be in cash that one time if you put charge, one count is reducing. So you can clearly see here with the traditional LFP, I can charge only 3000 times and I can discharge for 3000 times. But if you use effectively, it will come for around 4 to 5 years. There is no issue. So now advancement has been done and we are bringing into 5000. So you can charge for 5000 times and discharge. So you can use your vehicle for more years. So that is for energy density enhancement. And when you go for fast charging, your battery gets deteriorated. So always you should not go for fast charging. Only if you travel on the way of travel, when you want to minimize the hours spent while charging, then only you should go for fast charging. Otherwise, you should go only for normal mode of charging. So next is the sustainability and curricular economic in battery production. So when you say, now we all know that we are in the era of industry 4.0. So now we are even moving to industry 5.0. So in under this, everything is mechanized. So once mechanized, then the manufacturing error will be reduced. Thereby your efficiency will increase. So that is the sustainability and circular economic in battery production. So now we talk about production of battery, not utilization. So when you are in production, your company or the battery manufacturer, they have moved into industry 5.0. And even there's a small difference between industry 4.0 and 5.0. So industry 5.0, you will have twin, which means there will be a one mission and another one is really virtual. This virtual will monitor the machine which is being used in the production. Okay, then the next one is the sustainable production properties. Battery storage cost declined 93% between 2010 to 2024. Again, that is a major achievement which has been done. So what we have done is we are going to install a solar panel. So during daytime, I will get power from sun, and that power I am storing in my battery. So which means this power will be used during peak hours. We all know what is peak hour. So peak hour of power utilization is morning 6 o'clock to 9 o'clock and evening around again 6 to 9. But at that time solar power will not be there. But so what we can do is put a solar panel, get the power, store it in the battery and use it during 6 to 9 as well as in evening 6 to 9. And similarly, from that you can use for charging your electric vehicle also. That is the photo which is been showing there. You can see there are some vehicles which is getting charged up from these very huge battery resources. And in this method, your cost is declined. So thereby we can able to reach our requirement. Then the one more thing is you have to understand the term called second life application. That second life application is when you buy an electric vehicle. So let us assume you have run it for 5 to 6 years. Assume that we have done charging at a proper manner. And end of the 5 years, if the battery fails, it doesn't mean that all the cells in the battery has failed. Either few will be failed and remaining will be healthy. So what we should do is we have to take this battery, put it in a grading machine and try to separate it based upon their character. So among, see, if you're making a battery pack with help of, say, let us, we take 50 cells and made a pack. Once we say it is dead, among the 50, around 10 will get been destroyed. Remaining 40, what you can do is you can again reuse it, but that reuse cannot be brought to vehicle for some other applications. So you can have an battery option available with your tube lights, then your ceiling fan, because nowadays we use only BLDC fan. So you can use this battery for fan. So in future, what will happen is there is no need for UPS at home. Rather, all will be self-supporting one. Your tube light itself is self-supporting. Your fans will be self-supporting. So thereby they will use their own inbuilt lithium phosphate batteries, which has been placed inside the unit itself. Thereby they will run. Okay. So move on to the next slide. This is one more thing we should all know. This is I have taken from Chinese side. What they are doing is you can see clearly. Uh, you should start from solar. So from solar they are getting the power. That solar power they are going into for charging station. In charging station they use batteries to get charged. The battery is not the vehicle battery, charging station battery. Okay. From the charging station battery, your vehicles get charged. So this is one word or one direction movement. Now what we can do is we can even step in to a next level, which is nothing but supplying this power from the battery to the grid. Okay. So this is, I think, once in 4 5 years, this will come into India and this will become more successive method because let us assume we all know Phoenix Mall in Chennai. So if all the two-wheelers coming from outside to Phoenix Mall, let us assume let it be an electric vehicles. So what you will ask them to do is connect it to our charger, which is there in Phoenix Mall. So now what happens is Phoenix Mall itself is becoming like a power station. Assume one vehicle as I'm just for assumption I'm saying just one vehicle is say 1 kilowatt. If you park 300 to 400 vehicle, it will become 500 kilowatt, or more or less it is nearly to a Kalpakam. What you are generating power from a Kalpakam station single unit. Now your Phoenix Mall itself will have a total battery capacity of around Kalpakam power. So what happens is if suddenly EB wants any spike load is there, a sudden load, they can take this from your electric vehicle and they can supply it to the end user. So what happens is no need to go for sudden operation or increase in power production from the power plant. Rather, you can use this power. Okay, so at that time, what we will do, we will monitor our battery health, we will monitor our charging status, we will use the energy flow, and usually we will pay back. We have a tendency that why should I give from my two-wheeler? That is not the case when your two-wheeler is in parked in Phoenix Mall, and if your power is being drawn, rather charging your battery, if the power is drawn, you will be credited with some amount. Okay, so it will be vice versa. So for that, what has been done in China, which is already there, smart battery management system, which is an AI powered. So based upon the data from the battery to the battery, all such things will be monitored. So based upon the monitoring, we will decide whether that particular vehicle can supply or that particular vehicle needs charging. So you can see here the concept of vehicle to grid technology enables EV to support grid stability during peak demand. So this is the thing which is going to change the future. So in future, you may charge your vehicle from suddenly if I want, I will use it and I will pay you back. But this will leads to saving of money to a greater extent for power grids. Okay. So all that is coming up already is there in foreign country like China. And I think it will not take much time to enter into India since our development is at a very faster compared to other countries with respect to product development. I think we all have eagerly we are saying sir startup consultancy project as we are faculty members we know and that startups are being encouraged. So thereby if you do research on charging, how to connect it to grid and AI based charging, AI based grid integration, if we able to do project and come out with the product, you are will be most welcome and you are the person who is going to earn a lot. Okay, just come up with product, go for patent. Then once you get a patent, start up. There are, if you are interested, you can even after this FTP also you can ask related to funds how to get startup and all because government is have a very wide opening now. So since while introduction they told I have received 15 lakhs. So I have done my prototype. Now I am proceeding with the next step that the government is ready to give 1 crore. So in that case, what I have done prototype will be made as a product and that product will come into market and thereby our import will come down.
Let me know. I'm here to help anytime.
So just I'm showing this for global EV scales, sales of and battery demand outlook. So whenever any new technology comes, then China will be in the first, followed by European countries. Then we go with North America. Then Asia Pacific is like India. So now in 2024, we are in 1.2 million units and our battery demand growth is 45. So you can be say very clear. We can understand that from this particular line, government initiation and affordability is increasing. So this is the status of India. You can clearly see, even though China is of sales of 8.5 million with a battery demand growth of 30, we have crossed them. Now we are in 45 and our projection is further we will go by 12% before 2030. Okay, so we are in the stage of crossing. So surely we will come into picture.
Search side project is department visualize by focusing on the accents, industry lens,
Then future outlook. So when you see future outlook,
emphasize excellence in
battery technology roadmaps. So in the year 2022, it was around slightly less than 150 target cost per kilowatt hour. Hello, sir.
Responsibility. The department mission has.
Yeah.
Hello,
Hi, sir.
sir. Some more voices is getting added.
Unmute, sir. Unmute.
Like more details for one of the mission statements as well. Just let me.
Yeah, thank you, sir.
Coming, sir.
So the key strategic properties, the battery industries is focusing on cost reduction, performance enhancement, and sustainability initiative to accelerate EV adoption globally. So investment in R&D, supply chain reliance, and recycling infrastructure are critical for achieving net zero emission target. So around 75 total cost per kilowatt by 2030. That is the target they are trying to fix. So we will be slightly greater than country like US or China, but we are also taking step towards the battery cost reduction. And The battery packs architecture and integration. We say cell configuration. We know that it is of serial parallel arrangement. So lithium ion cells delivering normal of 35.5, that point is missing there, voltage, and it is around 75 kilowatt hour capacity, achieves 95% energy density with the property of cell spacing algorithm. So which is nothing but what I mean to say is, you can see this diagram, there should be some spacing between the cells. We cannot have more space, but you should not compress such that there is no space between cell configuration, because there should be some area where the heat should come out. So once if the heat come out, automatically your battery will work for a longer duration. Since we are a country where our normal temperature will be more compared to Europe or any other thing. So when you manufacture, the thing which we have to is cell configuration. So you have to configure such that, see, when you take as a battery, it is made up of cells. So there should be a gap between each cells in a such a way that heat has been traveled outside. So that we should take into consideration. Next one is battery management system, that we call it as BMS. So when you see BMS, it is a real-time monitoring. We say real-time monitoring is 100%, 100 plus parameters, including individual cell voltage. So if you have a pack of cell, let us assume 100, then for that 100 cell, I have to measure the voltage. The 100 cell, I have to measure temperature. The 100 cell, I have to measure state of charge. For the 100 cell, I have to measure state of charge and health. Similarly, the current drawn by the cell. So all this is required. This is to say that no cell should be overloaded or not being used. So that you have to continuously monitor, and then your battery management system should take care of it. And the third one is thermal and structural integration. This is correlating with cell configuration. So similar to cell configuration, why we go for it is to reduce the thermal. Since already our country, we are slightly at a higher temperature compared to other countries, uh, the thermal should be taken care. So the mechanical faculty and the EEE faculty can jointly do research. So any guide from EEE background can go with mechanical scholars. So they can develop an algorithm for this thermal runaway problem or thermal, because mechanical they will have a more knowledge on thermal analysis, like they will go for FEM, finite element analysis, for doing thermal studies. There are a number of softwares are there. So with that we can try to do research and try to prepare a battery pack, thereby similar to your BOS, sorry, battery management system, you can have thermal management system also, which can be developed and which can be placed inside the battery and which can be sold out. So at any point of time, you can give an indication to the person who is using the vehicle that temperature is within the limit. If the temperature is crossing, then we can give some warning signs like, please park, see, please don't drive the vehicle for few hours, or give a gap. Okay, like that we can do. And the next one is battery degradation and life cycle management. So when your battery will get degradation, or when the battery is being moving into the problem of failure, only two things: one is temperature stress, then the charging pattern, then aging. Once you bought your new mobile, and if you charge at night and use in the daytime, even in the evening, you will have more than 50%. But the same mobile, when it's after 2 years, automatically by evening, your charge will not be even, what to say, 20%. Same case for electric vehicle. So the calendar aging, this term calendar aging, we call, after a prolonged usage, there will be a reduction. So to have this issue, how to overcome is, you have to optimize the thermal management. Then you should go for smart charging algorithm, then predictive maintenance AI using AI. So these three are the solution for these three issues. So these three issues will come. If these three issues is not properly addressed, obviously your battery will get degradation. So go for proper planning. So proper planning is proper temperature stress, proper charging pattern, and for calendar aging. So optimize the thermal management and smart charging algorithm and predictive AI based maintenance has to be carried out. So battery testing standards and certification. So when you start up an industry, you will come to know. So the company, what we start in India currently is we import cell from China, and this imported cell is being used for preparing battery pack and providing to the end customers. So there are so many test certification required. So one is for safety testing. Usually this course is around 6 to 8 weeks. So you can attend and get the certificate for safety testing laboratories. So this is like a third party testing method you can earn. So you will not be manufacturer, you will not be end user, you will be a third party person to test and give the result. Similarly, performance testing, that is also you have a certification for around 4 to 6 weeks. Then environmental testing. Environmental testing is the third part. This is comes into picture once the battery is thrown from the electric vehicle. So once this battery is thrown from electric vehicle, then you cannot directly throw it in dustbin or you cannot give it to roadside. You cannot put. So there should be a proper environmental test it has to pass. Then only you can dispose it. For that also you have certification like 5 to 7 weeks. Last one is international standards. This international standard is for manufacturing companies. It is like UN 383, IEC Indian Electronics Certification 62619, and this is around 8 to 10 weeks. And this we will not opt because we are not going to go for manufacturing. We will go for buy the cells and do the packing. There you need performance testing, and the safety testing is anyone can get the certification, get the required setup, and you can go for safety testing, which can be given to the cell manufacturers. Next is charging infrastructure and ultra fast charging. So when you go for charging, there is three type of charging method we will call: slow charging, fast charging, emerging wireless charging methods. So when you say slow charging, that is with respect to amp level we speak. Maximum of 5 amps will be from my side. That is the vehicle when you put for charge, the maximum current drawn by the charging station will be 5 amps by the vehicle. So when you say fast charging is nothing but raising the current level, you will raise it to 15 amps or even further. So there are some thing which is going on. You will go beyond or equal to 20 amps. Beyond that, we will not go. So that we will call as fast charging. And the third one is wireless charging. This is the way by which in highways you must have a separate road of around 1 kilometer or 2 kilometer side of your main highway. So your vehicle charging is reduced, then you can switch in from this highway and move into that particular road and travel for 2 kilometers at a very slow speed. Thereby, charger will be placed on bottom of the road. From there, like our transformer principle, there will be another coil which is being placed in your vehicle. By induction, this two coil will come in not mechanically, electrically coupled. Thereby, it will get charged. So you can, if you are ready for any investment, you can invest like this before your house or before your workplace. You can invest and buy a charger and place it there. So you will get an income. Even one or two is also, even just you at your front edge of your home, if you just connect one single charger, you can go for normal DC charging. That the method one. So whenever a person is charging, you will earn. So next is your fast charging methods will be placed during any front of restaurant or any place where they come and get charged for around 10 to 15 minutes. And wireless, government has to take initiative that we cannot do, or any big shots who play with government, they can ask for permission and they can establish. Then we move on to the next type of battery, which is sodium ion battery technology. So moving from lithium phosphate, the main drawbacks in lithium phosphate and all, the raw material, we are not abundantly present in India. We depend on other countries, and even that cause a little bit of pollution. So our country doesn't allow for getting polluted by the raw material and in manufacturing. So when you move on to the sodium ion, the material is cheaply available, that you can see here, 30 to 40% cheaper material than lithium ion batteries. No expensive cobalt or nickel is required. So cobalt and nickel are little bit costlier elements. The raw materials are abundant and widely available globally. Sodium, we all know, it is just from common salt. So common salt, you can get it from sea, no issue. So abundantly available on earth space. Okay, next is performance merit. So 150 to 600 kilowatt per kgd density, which is can be possible from sodium ion, which is be slightly less than lithium, but we reach 80% of what lithium phosphate. So if you are able to say 160 kilowatt hour per kg, your lithium will be greater than some more 20% over this, but okay, 80% of lithium, if you are able to get from sodium, then it is very good. And then by using sodium ion, thermal runaway problem will be less. It is not as compared to LFP, where LFP are prone to increase in temperature while in operation. This is not the case. Then market timeline. So this is now only it has started. So projected is 15 to 20% target by 2030. Anything when come into market, initial 5 or 6 years, percentage will be less. Then it will gradually increase. Currently showing 200% year over year growth in R&D investment. So compared to last year, now it has gone to a greater extent. Then solid state battery technology is traditional lithium ion structure. When you compare the conventional liquid electrolyte system, in inherent limitation in energy density. So when you compare with the lithium ion, this fellow has higher energy density. Then it is totally solid electrode. So there is nothing going to be leak or move out, or there is no need to place in a particular position. You can put it in vertical or horizontal, whatever way we want. Then comes reduced retardate formation. Since we use any lithium ion and all, there will be a white deposition around the plus and minus terminals. All that will not be there in case of when you go for sodium or solid state. And enhanced energy density we will get, and there will be a full commercialization target by 2030. We say it will be fully commercial. Then comes battery safety measures and thermal management. Just a repetition of what I have told. So it is not that we all move into electric vehicle is more important. Move to electric vehicle, but that should not lead into any issues. Okay, so always you have to go with safety mechanism. So thermal fuse should be there, separate shutdown, then multi-layer protection. So this is again just I'm showing there, you can go for research. If there is any scholar is approaching, then we can ask them to do research on this area and you can come up with an product. Okay, thermal management. See, now interdiscipline work is highly appreciable. So any scholar from mechanical or computer science has to work with electrical in future. Okay, then thermal management, heat dissipation system, we can work on. Then thermal conditioning materials we can work on. Then we can go with active cooling methods. There are so many active cooling methods. So we will try to pump some external fluid for cooling the batteries. This is usually not required in two-wheelers or four-wheelers, but it is required when you go for charging a very huge battery. What I have shown now, a solar panel with solar panel, a big battery setup. There and all, we have to go for active cooling solutions. Then comes your modern battery manufacturing process. This I think I have already told. We will go for industry 5.0, which is AI powered. AI powered will be there for testing, assembling everything. When you say you have prepared a pack, that pack will go to AI testing. AI will test and give me the report. So no need for manual testing, AI testing. The only advantage with AI testing is result will be acquired. But the thing you should remember, AI cannot rule human. Only human can control over AI. AI is just a tool. It cannot replace human. Only unskilled labors will be reduced, but a technical background people will have their job. So we should not get misguided that once AI is brought in, we will all be sent out. That is not the case even for teaching or for industry. It is only, it can support us, but it cannot take the entire rule. Okay. See, even AI can take class, but while taking class, it cannot monitor whether the student is sleeping or is listening. That AI cannot do. Even that also, if you say I will put a camera and I will visualize, everything is good. But we will able to identify by seeing the face of the student whether what type of mentality is. See, nowadays a parental guide is required by the faculty that cannot be done by our AI. So the year in modern battery manufacturing process, so entire thing will be with AI and robotics, and automatically that electrolyte coating and all is not required for solid state battery. Rather, we will go for precious coating lithium components with 98.5 uniformity achieving through automated system. That is what I have told. Only if you go with the AI, the quality of the product will get increased. So obviously, we will move towards industry 5.5. Okay. Then the materials, there are three material which we call it as lithium. Next one is cobalt, another one is nickel. So global reserves 21 million tons. That has been as told that much availability is there. Mining locations in Australia, Chile, and China. Application is EV, consumer electronics. Price tends to fall by 18%. When you move on to cobalt, risk in handling cobalt is high. Recycling current recovery rate is only 32%. Substantive development, nickel rich cathode reducing demand. So when you say cobalt, handling this cobalt is little bit tedious. That may even leads to explosion. We should be very cautious. The third one is nickel. Supply concentration is there in Indonesia, Philippines, and Russia. Purity is class 1 for batteries. We go for purity of nickel as class 1. High carbon processing. So when you want to take nickel and use it for it is an high carbon processing, which it emits carbon more. So environmental aspect you have to think. That is why your lithium has gained more than compared to cobalt and nickel. So this is just I am showing off raw material and supply chain management, that is mining, material processing, compound manufacturing, then battery assembly, and the final one is recycling. So start from mining, you go till recycling. So it is entire thing is closed loop. So whatever you take, you have to make it and again give back to environment in the same case what you have taken from it. So this is just a small thing that manufacturing phase is around 40% carbon footprint. So from naturally available raw material for making battery, from the raw material to battery, it is 40% carbon footprint is there. We have globally, we say we have to come down in carbon footprint. And while usage also you are emitting carbon, which is around 55%, then break even analysis, then finally end of life. When you say the battery is fully drained, which cannot be charged, at that time percent also it is going to emit 5% carbon. So again, in this area also we can do research such that how to reduce the carbon footprint. That is usually anything released in the form of like carbon dioxide, carbon monoxide, or any carbon which is being liberated, which is going to pollute the environment. So here also you have research area where we can do research on how to reduce carbon footprint. Then this what just I am showing to show a photograph, that's all. This photo automation and industry 4.0 photo alone is showing here. So you can see here there is a conveyor belt. Batteries are moving. So each and every arm will try to fix and solder each unit. So entire process being done by robot to eye precision. That is what we finally say. Usually when we visit a industry, we will see a notice board like 0.001 ppm, like sticker will be there in every place. That sticker is saying it is 0.001 failure per parts manufactured per million. So when you manufacture a million part, 0.001 is the chance per error. So that is because of industry 4.0. So by industry 4.0, the chance for failure of manufacturing product is reduced to a very greater extent. So cost analysis, battery price breakdown. So gradually battery will come down. So that will increase the application. So we have to move towards how this battery placed in electric vehicle can be used for other application rather than running the vehicle. So that we have to think and we have to utilize it. Thereby, it is an advantage for us. So that we call it as vehicle to grid. So not only for running the vehicle, you have to give something back to the grid, and from that grid, you can utilize for some other purpose. So V2G capability, EV returns 90% of energy backup. So whenever you are fully charged and if you are not utilizing, say let us assume when you take your vehicle from home, go to office, during the working hours, like 8 hours, at that duration, your vehicle is not in use. But if suddenly if you want power for EB side, I can draw from that particular vehicle. That we say it as V2G, vehicle to grid operation. So this is again one more tool developed. It is an app. So this app is for AI powered battery management system. So again, this can be taken as a research project by the scholars. So there are n number of electric vehicles available with doesn't have AI powered. So you can develop an app. That app can be installed and that app helps to monitor the battery of the electric vehicle. So that you can develop with AI powered. This again, um, for your just for reference, I'm saying DRDO are ready to give fund when you come with an idea with AI. Just title, if you have AI, they are ready to fund DRDO and with respect to battery. So you should have a battery, you should have some application, you should go with the AI. So with the AI, we want to do battery management system. Like that, if you are going, then there is a chance to get fund from DRDO. Even we have applied, we are in final stage, so we may get fund regarding the AI based tool for prediction of battery management system. So battery recycling technology and material recovery. This is more on chemistry background rather than our electrical. So it is merely on mechanical and chemical industries. How to recover the things from the battery after utilization. So that we call it as second life battery application. See, till here we talked about. So my entire presentation, if you have seen, I have started with the battery, then I have told types of batteries, then I have told how you are going to use with your EV, Then I slightly moved how to move to grid. Then how to move to grid, you should have battery management system. Then I told we should have AI powered battery management system for providing with the grid. Then finally, I'm going to say about second life battery application. So once the battery which is being used by electric vehicle, it is should not be thrown. So end of the cycle of EV battery, 80% capacity is remaining. Try to understand it is only 20% of the battery has gone. Remaining 80% is there. So we should come up with the new ideas. You can develop a tube light working on battery, fan working on battery, try to make a product, say that get the battery from the used electric vehicle battery and try to utilize it. So extend the life cycle value. See, just throwing out is nothing, it is waste. You have to reuse it. Thereby, that production's time CO2 emitted will not be there. Say, if you want to make a tube light with the battery, if you're going with the new battery, this manufacturing new battery might have emitted CO2 to air. Okay. Whereas when you are reusing, that's percentage of CO2 is been reduced. They say around 8 ton per battery. Usually it is CO2 emission. 8 ton per battery. That will not be there when you go for reusing. Then renewable integration, go with like you use this battery charging with solar, wind. Even at house, we can try to put a small solar panel, small wind. Thereby, we can able to generate. Okay. Then battery requirement for EV segment. I think this is I've already told. So these are the major manufacturer now. I think we might come across this two fellow. CATAL is car manufacturing company and BYD. I think in Indian roads we can see this BYD more. Okay, LG solution is not entered till now. More we see on Indian background is this BYD. They have got 30% of the market share globally. Integrated manufacturing. They manufacture not only battery, they started electric vehicle, they started vehicle integration. Their focus is on domestic EV market. So finally, their intention is to for supplying domestically. And other two, I think we might not be familiar. The CATL company is in more related with America. And this third one, LG Energy Solutions, they are not fully on electric vehicle, but they are on nickel, that is NCMA batteries that has been supplied to DRDO and all. DRDO and all, they have batteries from this LG Energy Solutions. So this is just I have gathered information. What and all the ranges where they are being used. So in residential, we are in 5 to 15% kilowatt. In buildings and commercial places is 500 to 100 kilowatt hour. And for utility scale, it is around 4 to 6 duration of batteries, which is in megawatt. In transportation, we are gradually increasing. So thereby we will reach our maximum height. So I'm running out of time. So I will be a little bit fast. I will share this if you want this. If you think it will be useful, I will share the PPT. So this is just to say about chemistry behind the next generation lithium metal batteries. So inside you can see the structure of the battery will be in this format where this is your lithium followed by a metal structure. So thereby the energy density is increasing. We need energy density with reduce in size. That is what we need. So in future, UPS battery at home now it occupies, let us say, 1/10 of the size battery will come down. So even you can, when you go to out of station, you can even carry your UPS along with you. So wherever you want, you can carry your UPS at home itself. So wherever you go, and similarly, there are batteries manufactured by lithium ion for UPS. You can even run your ACs at home, but it will be only tabletop size battery. But that battery will be capable of driving the AC at home. So that much high density, energy density manufacturing and technologies are available. So this is just showing the trends. So trends started from 2021, 23 and 24. So these are the various trends globally. I'm not talking with respect to India. So I think with this, I try to wind up. If you have any questions, I have even given my YouTube link. Usually I used to post. So even today by evening, I will post the what I have presented. If you think it will be useful, you can. Okay, thank you. Any queries or any questions?
Thank you, sir. Participants, any queries?
Thank you, sir.
Hello. Audible?
Yes, yes.
Hello.
Audible.
Yeah, sir. I have one doubts.
Yeah, tell me, sir.
In that wireless chargers, I have a lot of technologies because of like inductive charging, capacitive charging, and then RF charges. So which is more comfortable for recharge?
That is what I told, no, sir. Depending upon the application only, we can say we will go for fast or normal charging. See, when you design a product for highway where you are going to place near restaurant and all, you will go for fast charging. Nothing but you are going to pump more current rather than slowly pumping the current inside the battery.
Yeah.
But when you are at home, you should go for slow charging. And usually wireless charging is they say, but it is not been implemented. They are saying that we will place it inside near the traffic signal and all. So where you are going to stand for a while in a traffic. So if you are placing wireless at the bottom of near the traffic light and all, then it will be useful for in charging the electric vehicles.
Okay, sir.
Okay.
Thank you, sir.
Other participants, any queries? So shall we conclude, sir?
Yeah, sir.
Okay. So thank you, sir. Thank you very much for your sharing your knowledge in case of the advanced battery technologies. So you briefly detailed about the thermal issues, materials, research ideas, as well as the battery management systems. So this is mainly useful for all the faculty members, especially for the aspirants who are doing research in that area, sir. Thank you very much, sir.
Yeah, thank you, sir. Thank you for calling. Once again, thank you for calling me as a speaker. Thank you, sir.
Thank you, sir. Thank you.